So I'll just start with lecture 4. Okay. So in lecture 4, we'll start with geometric design. Okay. So we have seen the various geometric cross-sectional elements for highway, and similarly in railway track also we have got certain elements that we need to consider while designing the track geometrically. Okay. And the most important elements of a railway track are gradients, then curvature and alignment. Okay, these three are the important elements of a railway track. And why is it necessary that we have to design a railway track geometrically? So it is going to give you a smooth and safe running of trains, help you to achieve maximum speeds, will be able to carry heavy axle loads, and it avoids accidents and derailments due to a defective permanent way. And if you are designing by considering the above said factors such as gradients, curvature, and alignment, it may require least maintenance. And finally, it provides good aesthetics also. So these are the reasons why we are going to design the track geometrically. Let's move to the first element of a railway track, which is gradients. So gradients simply means that any departure. So these all things are basics that you have discussed in highway also. Okay, but of course there is some difference. So gradients means any departure of the track from the level. From the level surface, if there is any departure, maybe a higher elevation or a lower elevation or a dip. Okay, both are treated to be gradient. And in order to negotiate the rise or fall in the level of the railway track, we are providing gradient. And gradients are provided in order to reach various stations which are situated at different elevations. Not all the place or not all the railway stations or not all the places of a country are at the same level, right? Maybe Trishur is having a different level. In Trishur itself, we can experience like some of the places will be at a more uh, elevated area, and some will be at a lower, uh, like level, at a lower area. So in order to connect different places which are situating at different elevations, you need gradients. And whenever you are providing gradients, these are to be provided at a uniform rate, either uniform rise or uniform fall. And another reason for providing gradients, it is going to reduce the cost of earthworks. If you are not going to give gradients, then that means you need to either fill the place with earth, or else you need to cut out all the earth, right? So the earthwork, the cost due to the earthwork is getting reduced if you are providing appropriate gradient. So these are the various reasons for giving or providing gradients. And gradients are actually they are measured. The extent of rise or fall in 100 units of horizontal distance. Okay, how much rise or how much fall, that is the level difference in every 100 units of horizontal distance. Or else you can count for every 1 unit of rise how much horizontal distance is there. Okay, either you can express it by 1 by x, or else you can represent it by x percentage. Okay, And basically, gradients are of two types, rising gradient and falling gradient. So whenever the track rises in the direction of the movement of the traffic, it is known as rising gradient. Like when the movement of traffic, in the direction of the movement of traffic, if the track is rising, is going up, it is known as rising gradient. And if the track falls down in the direction of the movement of traffic, it is known as falling gradient. So always a gradient is defined with respect to the direction of the movement of track. So here you can see in this the train is moving towards this direction, and here you can see a falling gradient, and here the train came from this direction, so it was a rising gradient, and now it is going uh, down, so this is a falling gradient. Okay, and rising gradient is also known as up gradient, and falling gradient is also known as down gradient. So this is an example in which you can see both gradients, rising gradient and falling gradient, and the both way of representing the gradients, 1 in x or x percentage. Here 1 in x, 1 in 400, and x percentage, the value of, when you represent the gradient by 1 in x or x percentage, the value of x is not the same. Okay. So if there is a rise of 1 meter in 400 meter horizontal distance, you can express the gradient as 1 in 400 or else 0.25 percentage. So this is how you can express. Both ways are correct. Okay, both ways are correct. So that's it. Now we are moving to types of gradient. And so when types of gradients are asked during examinations, you need to write the definition of gradient. Okay, then you need to write what are the basic types of gradients like rising gradient, falling gradient, and again you need to list out these four types. Okay, with appropriate explanation. So the four types of gradients that we are providing in a railway track are rolling gradient, pusher or helper gradient, then momentum gradient, and finally gradients at station yards. Okay, these are the various types of gradients, and the explanation of this will be given in the next class. Thank you all, and you don't go, I need to take the attendance.